Hello, everybody, and welcome to this part 41 of the Arduboy dev stream. I still call it a dev stream, but actually, I stopped streaming it. I just record it and then upload the video on YouTube uh, because I had some connection issue before, so my connection was dropping. So yeah, I don't want to lose the stream in the middle and lose some frame, lose some information. So um, anyway, there was very few, if none, people watching live. So I think that's fine for me, just to record the video and then upload it later on YouTube. You can leave me, so if you still want to interact with me, comment whatever, you can of course leave some comment in the description, in the below the video. I mean, you can leave comment and below the video, and yeah, I will reply to it and even maybe show you some stuff in the next video if you have a very specific question or suggestion. Yeah, so last stream we sorry, I still keep calling it stream, it's easier for me. So last stream I end up the stream with something totally broken because the video was too long, started to be too long, and I was afraid that I could not fix the decompression algorithm in a very short period of time. So yeah, then that's probably a bit annoying also, to see me struggling, watching me struggling with the code. So I have fixed it outside of the stream, but actually it was not that difficult. There was no big mistake actually. So as usual, I will show you what I've done outside of the stream, and then we'll continue doing stuff. All right, so yeah, obviously the first so last stream I didn't commit, but yeah, I just after the stream I just commit exactly what I had. So it's maybe I should show you, because I end up the stream quite quite quickly actually. Usually I commit every modification before ending the stream. So what we have done, of course, change the ID by 15, because again we want the ID to be stored on 4-bit. So the maximum number you can have on 4-bit is 15, mm, from 0 to 15. And I removed the comment saying I have to change it, of course. Then in the map manager we split the function that give the sprite at the specific coordinate. We split it in two, one taking the wall coordinate, and then the wall coordinate is translated into level grid coordinate, and one function that just get the sprite given the level coordinate, level sprite coordinate. And this function now I just call them in the draw function directly, and this is a bit slow, but it was just for testing. I didn't change it yet, but I think I'll plan to today, or if I have time, I plan to change that to refactor it, because obviously you don't want to iterate, decompress the wall line every time you want to for every sprite you want to draw. And obviously here we are in a loop to draw the wall screen. So of course we should just do it inside the loop. All right, and then here, so here we have the function split in two, and we have our decompression algorithm, right? So in the map data, we had, well, temporarily I reduced the map to 8, and also had to get one variable that I remove after, you will see, to get the size of the level. And this is how we pack our data. So I temporarily comment this to bottom screen, but basically I just use a macro to pack the two ID into one char, and yeah, we packed everything, and every time we had nothing, I mean the empty sprite ID, the next number was the number of space, so it's like a RLE compression algorithm, and yeah, just the level by one. Okay, so that's just what we had at the end of the stream, last stream, and I committed like that. But it was not working. So after that, I just tried to fix the decompression. Was not that complicated. There was few bugs, of course. The first one here, at +1, because the target sprite, actually we increase the number of the sprites, so we count the sprite from 1, and then only after increasing, after maybe we can look it here, after increasing the number, we check and go to the and return the ID. So yeah, obviously I can add one here, would be easier than comparing with 0 actually. But the other biggest bug was, so this was just making a shift, maybe, as it's not a big bug. But the next one was, I forgot to reset the flag, the boolean variable here, the read nothing count. Of course, after reading the count, I should reset this variable to false, and I just just totally forget to reset it. That means that just the first time we read the empty space was correct. So basically now I reset it. And another thing also that should be done is that the test on read nothing should be checked first, actually. So if we have to read the number of count, okay, we read it, we put the ID1, as we consider ID1 as a number, as a count, as a space count. Then we reset the flag, okay. And another thing I change is the test that was outside the three if else. I move them, I split these two tests, and I move them directly inside this if. So if we are here, I know it is nothing, and if we are here, I know just return the ID1. Right, and this is exactly the same for the ID2. So actually it's the copy of code, and you will see later I have refactored it to remove this copy of code. All right, so I will show you. Let's update to this version, and let's compile and see how it looks like. So you will see it's not perfect, and I will explain you why in a minute. Compilation time. All right, so it works, kind of, but you see the level is shifted one time every line. All right, but we can start to recognize it. You can see the ladder, for example. You can see the ladder here. It's shifted, but you can see it. You can see the wall, the left wall. So what is the problem? Well, if you remember, when we compressed the line, then when I arrive at the end of the line, I sometimes added zero, a number that was useless, because maybe the number of index I need to store is not even, so it's maybe odd number, and then I just store one ID on the last char, right? So of course I have to pad to fill with something that is not read, like usually I use a zero. So oh, let's see that it's in the map data. Here you remember, I guess, this one, even for the first line, this zero is nothing, right? The last ID is a block 88, and then I have to complete the line by something, right? So actually, what I should have done is actually remove this zero and move the next ID here, and then move everything, and then and that's a lot of refactoring again on the code, and I didn't want it to do that. So why? Because as we have discussed during the last stream, when we implement this compression, I said I want to have compression line by line. I don't want to compress the whole data. So I wanted to find a way to do it line by line. And that means if later I implement the line by line, then I will have to unpack what I pack. So I should not change it now. Okay, so I was quite confident that the shifting of one was coming from this padding value. And then to fix that, then I had to move on to implement the line by line compression, right? So that's what I did in the next commit. So here, let's update to here. So for that, I use, let me show you that. So I removed the level size that I added, the variable. We don't need it anymore. But I added another array, which I call level line index. I put back also the size to 16 because I finished to compress the wall level in that commit. So I finished compacting everything. So go back to 16. But yeah, I had this new array, level line index, which actually will store the index. So this array is here, which store the index of the first sprite of the line. So this is the first line 0. Obviously, line 0, the index, the first sprite start at 0, and then I just count the number of ID that I have in this line. So that's 0, 1, 2, 3, 4, 5, 3, 4, 5, and then 6. So this ID is the ID number 6, is the sixth char in this level array. So yeah, the level array is still a one-dimensional array, but I use another array to store the index of every beginning of line, and I guess that's the same size than storing a pointer, which also int, because the memory is addressed on an int. On 16-bit. but maybe it's easier to do it like that. I mean, to generate the data like this. Um, and of course, yes, it's an array of int. Cannot be an array of char. Cannot, because this big array will be bigger than 255 for sure. Already reached 141 with only this 4 screen. So okay, so I don't need this variable anymore. And then that means what in the algorithm? Doesn't change a lot, as you can see for now. I just need a start and the end, start line index and end line index, where the line is starting and ending. And I use this, and of course I use the y coordinate that give me the first index, and the end I just get the index, sorry, the index of the next line. And that means now I can iterate, my for loop can iterate from start to end and only decompress this line to get the sprite, right? And just by doing this, so let's compile, I have both fixed the bug, so that was really the bug, and I also get back some frame rate. Yeah, surprisingly. So actually, with now the frame rate is quite reasonable. It's not as good as it could be, of course, but we have a frame rate back. So if you remember, it was too slow with the first iteration, right? Yeah, and then I have also compressed the 2 screen bottom screen, so now I have the 4 screen, right? Let me show you the last screen. Okay, so now we are kind of back to what we had before the compression. And if we look at the size, 26,174, which I think it's more or less like it was before. I mean, maybe no, I think it's even a little bit smaller than before compression, so it's good. But you will see, I've made more progress on that. I will show you now. So the next one, sorry, mixing all the screen. The next one. After that I was quite happy, so I did some small commit just to relax. And so I just changed some sprite. Okay, first I add these 2 pixels here in the HUD. So that's the statuette for the HUD. Yeah, I think it was looking too much like a smiley, a round smiley. So I prefer to have it more oval, I would say, or yeah. So I add these 2 pixels, and for the world also I was not happy with the small statue figure, which also I found a bit too much like a smiley. So I changed it to something like that, which is, you may think it's a bit weird, but let me show you here. But actually I think actually it works quite well because it looks more like a square and like the big statue. I think, and this looks a bit like the teeth, the mouth of the big statue. So anyway, it was just to have some relaxation after that. So yep, obviously just updated the sprite here. You will see it with the next update. Let's move on. What I've done after that. All right, so after that, I have started to also do some maybe optimization on the go back to optimization of changing int to char, right? Because as we have seen in the last stream, that could help. That could save a lot, not a lot, but could save some bytes in the progmem because obviously the compiler has to do less operation, less instruction. And there's one thing. Remember, there was a question that I left open during the last stream: is the map coordinate is a char? Is it a char, or can it be or has to be a int, right? And I didn't want to think at that time because to think about that at the time because I was focused on making the decompression algorithm working, all right? But it was a question I had left for later. Because as you can see, the is destroyable block alive was using a char. So that's why I doubt at that time. So I just think again, and yes, it is. It can be a char. Why? Because, okay, we have 255 maximum, and well, actually from 0 to 255, and actually each screen have 16 sprite on the screen. So actually, if you divide it 256 by 16, you got 16, which means you can have 16 screen in the big data, in the big level array, right? You can have 16 screen because 16 screen times each screen contains 16 sprite, right? And vertically it's even better because we only have 8 sprites, so you can have 32 screens. So actually that means our maximum grid of the level that I could be has to fit actually in 16 by 32, like a huge array of 16 by 32, which is already too much puzzle screen that we can have. Again, my target for this game is to have at least 20. If we can have 20 different screens, I will be happy. That would be my minimum target. Less than 20 is not really a game. It's I mean, then that means we spend too much time or we spend too much code on features and not enough on data. So yeah, I mean, totally the and this is something you have to keep in mind. So the level coordinate can be char. So I change it. I changed the int to char. I just renamed this variable to make it the same. Just rename it. And yeah, I make a char here. And here I just move this test inside the world function, because I assume if you call that function, the coordinate should be inside the screen, not outside the world. But when you call it with world coordinate, it can be outside of the screen. So I just move this if into the world function, and yeah, change to to char, just renaming the variable. And what else did I change? No, just this, just change this. So let's compile to see the difference. So we are at 26,174 right now, and if we compile, 26,118. So from 174 to 118. That's actually quite a good, quite huge. It's 60. And I think 60 is the size of one screen. So we actually save one screen of data. All right. The next, what do I have? So let's update to this. So I optimized the decompression algorithm after that. So basically, we add exactly the same code. So maybe I can show you here. It's no, I already updated. Never mind. The code here, read nothing, otherwise if the ID is nothing, otherwise do this. And this is the same, read nothing, otherwise if the ID is nothing, otherwise this. That's the same, only the ID, it's ID1, or it's ID2, 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 ID2. So basically this is exactly the same code. You can just remove. You could, I hesitate to put it in function, but then I didn't want to have a function call, so I just say, oh, that's fine, let's put it in a for loop. So just have a for, iterate on 2, just have one variable, the ID, and then I change at the end of the loop, I change the ID to get the second ID. But yeah, just rename this variable also. Yeah, and add some comment to the decompression. All right. And what's the size of this? (26,084). Get few more bytes because you remove the duplicated code. Of course, we reach 90% of the program. Before we were at 92. Huh? So, all right. Then what I've done. Then I continue to the chasing, to chase the unnecessary int. So in Rick, okay, that doesn't change anything, but just for the sake of doing it. Here, okay, that doesn't change anything. All right, this is a small optimization. Actually, the position of the main character is initialized with our checkpoint system. So there's no need to initialize this variable, and actually if you remove this initialization, you also save some code, you reduce the code size for a little bit. But for this to work, then the initial state had to be death, because in the respawn function here, checkpoint respawn, I check if I'm dead, if I'm not alive, to initialize my starting position, right? So just by initialize the variable with death and remove this, I can save some data, some program. All right. So obviously the collision is still an int for now, because the So the collision, it's the bit field that check which pixels collide, and Rick sprite is 9 or even longer when he's crawling, 9 pixels the width, and even longer when scrolling. So yeah, we need an int for that, for having a precise collision actually. But this one could be changed because dynamic count is 5. So I added some comment. This one could be changed also, dynamic count. Yeah. This one, and some 4. Yeah. All right, let's check how much we gain on that. So it was 0.84, and now we are under 26,000. Now we are at 25,946. All right, it's going down. Next, I remove unnecessary char in the custom Arduboy HUD function, right? HUD, okay, that's useless. That doesn't change anything, just for the sake of changing it. Here, some could be char, like this one, obviously from 0 to 8. Not all of them. There is still some int that had to stay int. Okay, let's check the size. And 25,936, very few. I think it was 40 something before. I forgot to check, sorry. But I'm sure you are following. Next, in the map manager, also replace the unnecessary int. In the physics, I think in physics there was nothing. Yeah, that doesn't change anything. Maybe this one, no. Even this, if the compiler could, because here you have a constant, so the compiler knows that this variable won't go above above 256, so I can use a char. But sometimes the compiler can is smart enough. But when you start to do operation like addition, subtraction, and stuff like that in the for loop, then the compiler doesn't take any risk. So, and then the map manager. Okay, so some X. Yeah, so remove item. The item is the maximum number of item is isn't char, is less than, it's 205. It's less than 256. The max updatable item count here. Obviously, I don't think we will have 255 item. I hope not. We can work with that constraint. I think that's enough. So so char here. The camera speed definitely can be it's really small, some small value for the transition of the camera can be char. This for loop, for loop, the update, and so let's compile. Now it's 25,936. $25,760. We are at 89%. We decrease we gain 1% more. All right, then let's continue. Update. All right, then I continue to think about optimization in the map manager. What did I do in the? Okay, yeah, I changed this, but this is useless. It's just for the sake of it. Yeah. So the camera X and Y. Do we need to be in world? Is the camera in world coordinate? No, actually no. And it's even written in the comment. It's top left corner of the screen position of the level in the big level array. So in the big level array. So and as we just discussed before, we will use a char maximum 255 sprite in the array. So if the camera is inside this array, then we don't need int to store their coordinate, right? For the camera and also for the target of the camera. And because we have this, small transition to adjust the camera in between the two sprite, yeah, if you remember that, it's almost maybe the second level, the second stream. We implemented that at the very beginning of this development. So I'm not sure you can remember that, but so we can change that to unsigned char. Yeah, because we will stay inside this big level array. And that means also this one, because this one is more recent, maybe you can remember. This one are also the same type. It's also camera position, but recorded for the checkpoint. So the camera position for the checkpoint, for the last checkpoint, or the camera position last time I enter into a screen. So if this one are char, then this one can also be char, right? And the function begin switching puzzle can also be char also. So here I cast it to int because I was not sure. This one is a world coordinate, so I'm not sure if the compiler will do this multiplication into int space, and it has to do it like that. So that's why I cast the camera into int, just to let understand the compiler that we want an int value here. We don't just want a char and then the number rebooting, right? That would be bad. Right now, that's maybe a potential bug for later. Because right now we only have two screens, so we don't have that problem. Even it will stay inside a char, but who knows? So I was a bit concerned here. Yeah, so here I forgot this char item. The number of item is on a char. Yeah, so begin switching puzzle. This can be a char. This is new target camera. This is new value. Everything is char. The new target, the target, etc., etc. And here, obviously, I had to remove FF. It's only a char now. And yeah, and that's it. Right, so let's try to compile that. On 25 584, so we were at 7 something. I forgot. Let me revert. Actually, let me try again. Update. 25,760, 25,760, and by just giving the right type for the camera, we are at 25,500. 584. So is almost a bit less than 200 a byte, which is quite huge. 200 byte. It's like, again, if one screen is 50 byte, 60 byte, that means 4 screen. We just say 4 screen of puzzle. That's crazy. So I was very happy actually to do this optimization pass on all the code, because that's totally free. I don't change any code. Hopefully I don't add some bugs, but we'll see. Yeah, and then what else? Okay, and then we have bug fixing. So after that, I finished to go through all the files and look at all the int. All the remaining int are necessary, in my opinion, right now. I mean, necessary because of the way we implemented it. Like, for example, the wall coordinate in int. But all unnecessary, I think, have been replaced. So then I've noticed some bugs when I played recently, and I wanted to fix them. So first I will show you the bugs, and there's one that was quite difficult to reproduce actually. That there was a bug when you were firing your bullet, you could kill yourself. I think the camera is dead. Let me try to unplug it and replug it. Last time by unplugging it, it was okay. Maybe I changed the USB. Yeah, I need to do deactivate and activate. Oh, it's a bit dark. Okay. All right, so the bug, I finally found a way to reproduce it. So let me show you, and then I will explain you the bug. Boom. Okay, I die when I fire. I die. Okay. So how to reproduce the bug? Let me explain you the step again to reproduce it. It's actually quite easy to reproduce. The first thing you have to do is shoot on the left. Shoot toward the left one time. Okay, then you die. Okay, and after respawn, you shoot to the right. Okay, as simple as that. All right. So what was the bug? The problem is You remember we constantly reuse the same 5 bullet, so there was one variable that was not reinitialized, and that was the one flag in the bullet. This flag here, the mirror X. So when we fire, if it's to the left, okay, we set the mirror property of the bullet. But if it's on the right, we don't clear that property. We don't unset this flag. And since we are reusing the same bullet, so basically I shoot to the left with my first bullet, then I die. So because I die, I respawn with all the 5 bullet, and then I shoot to the right. So I shoot again, shooting the same first bullet from the array of 5 bullet, and yeah, the flag was not reset in that bullet. So the bullet was moving to maybe the parameters was correct, was false. I was moving to the right, but my internal flag was wrong. So after that, this flag is used for drawing the collision and all that stuff, and the bullet was going through my own body, right? So that was pretty easy to do, just clear this flag. But I had some really big trouble to find this bug. I really try hard to and to try to reproduce it, to understand how to reproduce it. Um, so let's update this and check it. All right. And the camera crashed again. Uh, let's try to. Yeah, I have to constantly change the USB port after the crashing of the USB camera. All right. Okay, so shoot to the left, die, shoot to the right. All right, fixed. The next one is another bug. So let me demonstrate the bug. This one was when I was scrolling, and for example, I released the button, right? So now we are checking if there is a collision above the head, and if I just press the right arrow, I don't press down. Okay, I just move right. Normally the character should stay in crawl until there is enough room above his head to stand up, right? But the problem is when I switch the screen, then I don't detect any collision, and then yeah, then because there is no collision, he stand up, but then he stand up and is in the collision, so then it gets expelled from the collision on the right or on the left. So, and this is more critical in that direction because there is a spike. So I die on the spike. Right. So, what was the problem here actually? The problem is, so yeah, that's pretty quite a lot of change actually, and I didn't fully test it, so I'm not sure I break something or not. So, but yeah, the problem was in the rig, and it was here. Basically, if the coordinate, so we had a function is there selling above crawl, right? That function set the flag to avoid, okay, getting up, standing up. Um, and here, if the x was outside of the screen, I just say no, false. There's no collision, right? And then that's the problem. That's the main problem. So the collision, I stand up, and then oh, okay, all the problem. I could have changed this false to true, but that would have also created the same bug, the mirror bug. I will say, like for example, if actually there is no collision, then during transition I will not stand up. So it was not correct to implement like that. So then I start to look at the other code, and I noticed that just above the function above is asking the map manager, is there a collision at? And this function is actually checking the screen pixels, and if it's outside of the screen is checking the level data, right? So if we look at that function, and you remember maybe that function, I've refactored this function several times if you remember it, and then I decide to refactor it another time to make it even more correct or even more complex. So before, and it was written in the documentation, if the y, so I give this function was taking two parameters, 2 pixels, left and right, and the y in world coordinate. So basically, if the y was outside of the screen, so the platform was under the screen or above the screen, then I will in that case I will check the level data. This is basically this code here. If it's outside of the screen, I check there's static collision, right? But I was not doing that for the x. I was only doing it for the y. But I could also do it for the x. If the x is outside of the world, I could ask the level if there is collision on this x outside, or on right, or on left, right? So yeah, basically that's what I decide to do. I refactor it. And in the same way, I changed the parameters. Instead of taking 2 pixels, I took x and y, and then a width, a length. So then I will check on this row of pixels. Why? Because if you check that function for the crawling, we were using this specific function we wrote on Arduboy to check the y pixel in a row. But this one, for the grown or selling collision, I was only checking 2 pixels, one under the feet, so just 2 pixels. I guess I was maybe worried about the performance also, a little bit about that when we implement, or I just wanted to be just more simple like that. So basically, I changed this just 2 pixel check by checking the whole line, and here that makes refactor this and finally call the same function. So now I just call the map manager that's collision at with the same x, y, and the length. So for the crawl, I just use the same parameters that it was before, the length, and the wall x is the same as before. I didn't change the code. I just removed, of course, this buggy line. I don't need it anymore because this case will be handled into that function now. And for here, well, it's the same except that I just don't do the plus here. I just uh, give the width. So I just okay, take the width here and give the width here. Yeah, and basically that make the two function very similar, just different parameter for the x and width, right? So let's go back to the new implementation. Okay, so first I like before, I check the y. If the y is outside, above, under, so anyway, have to check the level. Because the wall line, if the y is outside of the screen, the wall line is outside of the screen, right? So there's no need to check the line at all. All right, so we first do that. I move these two line below because we don't need to do it if the y is outside. We can just skip it and just return here. All right, then I check also the x if it's outside. And finally, if both are inside, then I will check the line of pixels here. So yeah, just compute the left on screen. So I just call the same function that this one is there static collision at x y, because if the x is outside of the screen on the left or on the right, okay, and if there is collision, then yeah, just I can stop here and return. Because that function actually wants to check the collision on the wall, on the wall length, right? So if I have, the function doesn't tell you where is collision, if it's on the left, on the right, I don't care. I just want to see collision on the wall length. Is this function is mainly yeah for walking or crawling under or walking on top. Anyway, the same for the right, if the right is outside the screen. And then finally, if both no, if at least one of the two are on screen, right? And now I just maybe this test is useless. Maybe not sure. Well, can think about it again later. So yeah, so if the left pixel is outside of the screen, I have to clamp it and to start a bit to start on screen and reduce the width. That's how I did it, because this function on the on the custom Arduboy doesn't check if it's outside of the screen, so I just have to do it here. And I didn't want to do it here because I just wanted to give char also, char parameters, not int here. All right, so then yeah, I check the whole line of pixels. Let's look at that function that changed a bit. So the signature also, I remove the int return, I just give a bool. Again, that gives maybe some extra optimization. I changed the row, before it was the row, and now I give the y because I need to be more precise now. And you will see. And by the way, why I changed that is because before, only here, it was only called here. Okay, only Rick was calling that function. And as you can see, I was just checking if it not different 0. So actually I didn't care where the collision was. So the function was doing more than what I needed. So I just simplified to a bool. And if later we need to be more precise, then I can refactor again and give more precision. Yeah, so return a bool. So now I need okay, the row I compute it myself, and then I need to know which pixels on the y I need to check I check it here, return true, false. Pretty simple. Then, of course, the enemy was also calling that function. And basically, there was only enemy and brick that was calling this function. Um, which means this function becomes now more powerful because it can check collision outside of the screen, not only vertically and horizontally, but also on left and right. Uh, just just a minute. There is the assistant that think I call her, so I have to tell her to stop. Uh, mm, all right, I'm back. Um, yeah, so now that means the function is more precise, and yeah, the enemy maybe also won't go through the collision if they walk outside of the screen. Again, I think I will avoid that situation in level design, um, but who knows? Maybe if I have a scorpion, maybe a scorpion can move between two screens and then it will move correctly now. We'll see. Anyway. All right, so let's try that. Let's see if that really fixed the bug. I think it fixed the bug, but I didn't test it very carefully, very intensively. So all right, so oh, the camera has some issue again. Okay, so now we'll just move, and the camera is dead. Let me try to fix the camera again. Right. Okay. All right, so here I will just move on the left, but not down. Okay, just pressing the left button, and it seems okay. Yeah, and if I go in the other direction, again, I just press the left. Before I was pressing right buttons, just press left, and it seems okay during the transition. Of course, if I continue here, I will die if I just press left, but yeah. But I can then press down also to avoid dying. All right, so that fixed that second bug. Hopefully, I hope I didn't break the enemy code. The enemy seems to still walk. So you can see also the small statue sprite that I didn't show you here, for example, here, here, here. I don't know if you like it better or not. You can tell me. Let's try to help this guy. Actually, it's quite hard to go. Yeah, I can by cheating a bit. Let's remove that. Will he follow me? I'm not sure. I think he's deactivated. Oh yeah, the block is repairing. Ah, okay, so now I cannot fall anymore in between these two. All right, that's a problem. Because maybe because yeah, not sure why, but maybe the Y is too low. So we'll have to fix that, of course. But and also if you look at the code, it doesn't increase that much, I think. So it was this to fix was reasonable, I think. All right. So I finished to explain what I've done. Now we can try to, I wanted to optimize the draw function before leaving you. Maybe I will break again the rendering. Let's try to rewrite it, and then we'll see. And if that works well, I think we will have to start the level editor, right? Because obviously now it start to be difficult to change the map data, right, without the editor, because everything is compressed. If I change something here, I have to change something there. So it's less easy. So I think that will be the good time to implement the editor. All right, but I want to change that, right? So because I want to avoid calling this several times. Obviously here we need to remember the ID of the left, the previous ID, if you remember. That's for mirroring the big statue sprite and also mirroring the stair. So we can just save this ID into a local variable when we iterate. So let's see. I think I will start by copying some code here for the Y coordinate. So put a marker here. Start draw. Okay, so and so start line index will be yeah, I need to ask it for every y, of course. Whereas my x iteration is here. Okay, so I need to do that to put that in the loop. Again, we need int. So that's why. All right. And this time we have to iterate from we need to start from this. Okay, we have to iterate from the wall line here, but we can stop. We don't need to stop to the next line. We can stop a little bit earlier, obviously after writing 16 sprites. So I should probably not call it x. So do I need x here? Here, yes, I need x here for the drawing. Okay, so I guess I don't know how to write it, but I will probably need an x somewhere here, which I don't know what it is yet. But okay, I guess if for the first x we can just continue the loop. We don't need to draw. So we will have something like that. And I will call this function a bit with a different variable. Let's keep it for now because I don't know exactly. But I will call it I don't want to call it I. Let's sprite index. No. Let's call it I. Yeah, let's call it I. That's fine. Yeah, so like I said, I should this one is probably less than this because the space are compressed, so it's always less than the start plus the horizontal sprite count divided by 2. So I probably will could be less if we have the last screen totally on the right of the map, but this one could be bigger actually. So we could we could take the minimum between this one and yeah, 16 more. Or I can do a break of that loop. Probably I will do a break of that loop because I don't know exactly how long is each line of the current screen we are drawing. So anyway, so if the oh we have to count we have to count the number of sprite, right? And if the I is less than the start, we can just continue. And otherwise, if it's greater than start plus this, then we can break. It's not high actually. It's a sprite count because I is the iteration in the level, will be iteration in the level, but we need to have a yeah, sprite count. So we start from 0 at the beginning of the line. And if the sprite count is less than the starting draw sprite X, then we just continue, iterate on the line. And if we are after the screen, then we can stop iterating. We break and we go to the next line, right? Now I will get even more code to get the count. It's yeah, very similar to this, of course. So maybe we don't need anything, but let's copy everything for now. All right, so what do we need? I can read, so I read my pack ID from the level because I need to unpack it to count the sprite. That's my first ID. I can iterate on 2 as usual. I probably need that also. Yeah, don't know where to place it. So it's not sprite index, but it's the sprite count. So if I need to read a space, I increase with ID, I reset the variable. Of course, I should not do the return. So what happens if I No, I don't care. This I don't care. I just want to count actually. So okay, if I need to read the space, I read the space. Otherwise, if it's nothing, I need to read the space. And here I remove that. Otherwise, I just increase from one sprite, move one sprite. But yeah, I need to draw them also. So I need to draw them. Okay. Yeah. That's fine. So this is where I said I should memorize the current ID and the previous ID also. So previous sprite ID. Actually, I will use nothing. And current sprite ID also. So I can just use that. I'm not sure if maybe I need a temporary variable just in case this is well, maybe not. Okay. So I guess I cannot have this for loop. We cannot have this for loop. We have to well, the thing is we need to draw the first one and the second one. Or yeah, and I prefer to go through all the code below to draw the first one and the second one. Maybe we will need a function to make the code more handy. I'm not sure, but so that's a sprite count. All right. Okay. Now I think the x can just increase. Before it was just the x was in for loop. So yeah, we will draw one by one. So I guess this is simple. I can just initialize x with the starting. Did I delete the for loop? No, it's just here. Okay. So I initialize it with this one, x. That's my current x. And then every time I pass here, I can just increase it. Or I should, no, I should probably increase it at the end, of course. So here. Increase X to draw the next sprite at the right position. All right, so that will be the equivalent of this for loop. Start from here, and then I will increase every loop. And yeah, I didn't copy the total everything, so that's my mistake. Here plus and draw sprite X. Check if we reach the beginning of the screen or the end. Maybe there is some simplification that could be done. I'm not sure. On with the X, maybe not. Well, it's better to keep it like that, I think. All right, so now we have this two loop to, well, this loop actually to try to remove. So how can we do that? Right idea. So basically what I want to do is to use this one here and to replace this one. Okay, so obviously I don't need this sprite ID variable. So yeah, let's just replace it. Or just replace it. Okay. So I don't need this anymore, and I want my previous sprite ID to replace this test. Sprite -1 blah blah blah. That's my previous sprite ID, and this is also my previous sprite ID. All right, and then here my previous sprite ID, let's set it with the current one. previous sprite ID with the current one for the next loop. Okay, so basically that's what I would like to do. Then that means I remove the 3 call to the decompression function. But now I need to make this work. So if the current sprite ID is nothing, maybe if I want to move that loop, maybe I can merge that loop with that one. Right, that's what we want to do. So that means I don't want to increase I want to increase I one time every 2 loop, something like that. And here the only change will be either I do this or I do this to get the current sprite idea. So I can probably use a Boolean flag. Is reading high bit. So we start with true. So either we read this or we read this. Then I remove this loop. And let's say we will increase so only if we're reading the low bit we increase the I, otherwise we will read again. Yeah, that means I will read again this time, this one 2 times. I can put that variable outside and yeah, let's try that. So if we're reading the I bit, we first read the whole char from the level, then we take the high bit. Otherwise, if we are not, then we are just reading the low bit of the same pack ID. All right, and then I have to reset. I have to change this variable, of course. Where, I'm not sure. Probably at the end. Switch, so invert the boolean flag to read the low or high bit. Yeah, and then increase I iterator only if we need to read a new char from the level. So first loop, read the high, then this becomes false, so we don't increase I, so it's false, though we will get the low. Then at the end, this is false, becomes right, becomes true, and then if it's true, we increase I, so we will read a new char, read the high. Okay. That may work. Now what about this? So I didn't declare this variable yet. Of course, we start with false. So if we read the space, we increase the sprite count with the sprite ID. We set the variable to false. Otherwise, if it's nothing, then we set it to true, and we need to continue. Yeah, actually we need to continue, but we need to continue by doing this. I'm not sure if I can do in the for loop here, if I can put that in the here. I'm not sure if that compile. Probably not. Cannot put two. Okay. But let's think about it later. And the current sprite will be, yeah, so the current sprite will be overridden, so I need to also reset current sprite here with nothing. After reading the count, I need to reset to nothing and reset this. So here we need a continue, but otherwise we have just the normal sprite count. Okay. All right, so I want to avoid duplicating that. Maybe I can use a modulo to increase I. I would be smart. Maybe. I don't need a modulo. It's already 0, 1. Hopefully it's 0, 1. Otherwise I can just use a char for 0, 1. So, but actually this is true. Can I just duplicate this, maybe? And we have another continue here. That's the same problem. I'm wondering if I can... I think maybe there's a syntax in the for loop to put two variables. I will copy it for now, and I think that can be rewrite. All right, so does it work now? All right, so we iterate on the Y from start to the vertical screen. Okay, then we get a start line index and line index from the line array. Okay, that's the same. We initialize x with the start draw. We count the sprite. We have the previous sprite, the current sprite. Flag to read if we're reading the high, and not flag if we read the empty space. And then we iterate from on I for the level array from start to the end of the line, even if we will break before that. And if we read the high bit, so we get this. We read the high. If we read the space, we add to the sprite count, and that's a nothing. If it's a nothing, then we need to read the space, and we switch this and we continue. Actually, that could be even probably even simplified, because if it's nothing, we don't even need to. Maybe yes. I'm thinking we don't even need to do the rest, and even we don't need to draw it, to draw a empty sprite, right? But there is still some code to be set, like the previous one, the previous sprite ID still has to be set for the stairs if it's nothing. So we'll see that later, but that's probably the idea. Okay, right. Otherwise, we just increase sprite count. The sprite ID is correct, and we're checking if we reach the beginning of the screen or not, or the end. And then that's the draw function. Let's try to see if that compile. I think that's my oh, that compile. Okay. 25,830. Of course, we added more code, but it's really for improving the frame rate. So, all right, let's try it. I'm afraid we will have garbage on screen. Yep, we have we have garbage on screen. Yeah, and the camera's dead. Yep. All right. Not surprising. It seems that everything is compressed. It seems that the nothing, the space are not printed. Why is that? Why is that? Sprite ID is nothing. Previous sprite ID, core sprite ID. Oh, we don't have. Yeah, we have removed the nothing from the walls. So actually, it's outside of this. So the nothing is not. Yeah, nothing doesn't go here, but the x should still increase. The x should still increase. Start from initialize from here. For the sprite count is initialized here for every line. That seems good. Increase here or here. The x is initialized here. The previous loop was like this, so from x here to this x plus plus. There's no reason. But I iterate on I iterate on I now. So every space, so actually I should x is not just +1 it's sprite count. Is it sprite count? Yeah, actually, x is sprite count. Yeah, so here when I count the space, then we increase by this. Yeah, so let's remove sprite count and just call it x. We start from 0 and we increase x. So we are finding back our for loop here, and of course I remove this at the end. All right, so we start with x equals 0. Here this is just iterating on the line, and here we increase, and here we test. Yeah, okay, let's try that. Let's compile. Okay. I need to fix the camera again. Oh, it seems that I like what I'm seeing. It works. It seems to work. And I feel that the frame rate feels good. Seems quite fast. Why I cannot go down? Okay. I cannot fall. Oh, we break something. We break the transition. Oh my god. We are on the second screen, but the first screen is still drawn. All right. Let's try to go on the left screen. Ooh. All right, so we break something with the camera and all that stuff. But we have a rendering of the level, which is good. I will stop the stream here. Let's commit that, and I will fix the algorithm outside of the screen. So yeah, so basically, yeah, the start and line, all the code to read the data. This is the test to start and stop the loop. And yeah, and just the current sprite ID and next sprite ID for to avoid calling this function, which was uncompressing the whole level every time, so that was a bit too expensive. Okay. Yeah, I'll fix that later. All right, so refactor the drawing map function to optimize it. And yeah, and that's it. So thank you for watching, and we'll see you in the next video, and I hope you like this one. So bye bye.